Welcome to the deep dive, where we take that pile of articles, research, notes you've got, and really pull out the golden nuggets. Today, we're doing a really fascinating deep dive. It's into something that's quietly, but I think quite rapidly, reshaping how AI works. We're talking about AI agents and the Model Context Protocol.
That's right. It's a pretty significant shift.
Yeah, I mean, you're probably familiar with chatbots, right? Those AIs that chat back and forth, predicting the next word. But imagine an AI that doesn't just talk. Imagine it can actually do things like pull live sales reports, check your inventory, update customer records, even write and debug code out there in the real world.
That's the agent world. It's definitely where things are heading.
So today we've got this really comprehensive stack of sources, deep dives from a top consulting group, stuff from various tech companies, developer guides, security analyses, quite a mix.
A lot to unpack.
Exactly. And our mission really is to show you how AI is moving beyond just conversation, how it's becoming these autonomous doers, and also the crucial role this new open standard, the Model Context Protocol, or MCP, plays in actually making that happen.
It's the connector piece in many ways.
Right. So, okay, let's maybe start by tracing how we got here. From those simpler chatbots to these, well, these autonomous agents.
That's a good.
So for a long time, AI models, they were mostly about next token prediction, figuring out the next word. That's how most chatbots work, fundamentally. Great for generating text conversation.
Yeah, predictive text, essentially.
But our sources are all pointing to this pretty big shift. We're moving past what some call agentic if statements, sort of simple triggers towards what are genuinely autonomous agents.
And that's a key distinction.
Yeah, these aren't just fancier chatbots. They are foundation models, yes, trained to chat, but also trained to use tools to plan, to reason through complex stuff. And this is critical to communicate and coordinate with other systems.
The coordination is huge.
So what's the really big practical difference here? When we talk about moving from, say, prompt chaining workflows to autonomous agents, what does that look like based on the sources?
Well, prompt chaining, it's like a fixed recipe. A predefined sequence of steps. You set it up, it runs A, then B, then C. It's great for processes that need to be super consistent, very predictable.
Okay, like an assembly line.
Exactly like an assembly line. But autonomous agents, they're fundamentally different. You give them a high-level goal, right? Like summarize the latest market trends for electric vehicles. Then the agent plans how to do that. It reasons, maybe it needs to search news databases, maybe check financial reports. It executes actions, like running those searches. And here's the key part. It observes the results in real time. Did the search work? Was the data useful? And it adapts its plan based on what it finds.
Ah, so it can course correct.
Precisely. That makes them less predictable, sure, but way more flexible, more capable of handling novelty, closer to, general intelligence. It really is like going from that basic calculator to a smart assistant who can figure out how to solve a problem, not just compute a preset equation.
And the sources show this isn't just theory, right? There are actual results coming in.
Oh, absolutely. The proof points are compelling. And what's really striking is just how fast these capabilities are maturing. I mean, the techniques, the frameworks, the actual examples, it's all advancing incredibly quickly.
So who's involved? Is it just the big players?
Well, you've got established players like OpenAI with their assistants, Microsoft's Copilot. They're all evolving their agent tech. But you also see new players jumping in, lots of growth in low-code platforms, making it easier to build agents. And the knowledge sharing is accelerating too. Companies like Anthropic, Pedantic, LangChain, Hugging Face, they're publishing detailed guides, sharing what they're learning. It creates this really fast feedback loop.
And these aren't just doing simple things, I gather.
Yeah, not at all. The sources give some great examples, like Bloomberg using compliance agents to rigorously check facts, minimize errors. They apparently cut decision time by 30–50%. That's significant.
Wow.
Or Booking.com, Jane Street, using coding agents to handle routine development tasks, cutting cycle times by over 30%. It's like the AI handles the grunt work, freeing up experienced developers for more complex challenges.
That makes sense.
And one consulting group even mentioned delivering over 300 of these Gen AI agents across more than 100 clients. They saw cost reductions up to 90% and big productivity boosts.
Okay, that's impressive, but how reliable are they? Especially when things get messy, the edge scenarios you mentioned.
That's the million-dollar question, isn't it? And it's something the field is actively working on. Benchmarks are evolving fast to measure not just task completion, but how well agents use tools, how they handle things like missing information or a tool not working as expected.
Right.
But what's truly remarkable, almost mind-bending, is a trend one source highlighted. The link of tasks that AI agents can reliably handle, let's say with 50% reliability, has been roughly doubling every 7 months for the past 6 years.
Doubling every 7 months?
Yeah. If that trend holds, think about it. By the end of this decade, AI systems could potentially be carrying out projects autonomously that take a month to complete.
A month-long project. Wow.
It's staggering. But that capability, it depends on continued progress across a lot of areas. Reasoning, autonomy, memory, reliability, and critically, integration with the outside world.
Okay, so that integration piece seems key. These agents are becoming incredibly capable, these powerful brains. But the sources really hammer home this challenge. How do they actually connect to all the real-world data and tools out there?
The bottleneck.
Yeah, because traditional models, they often work off static data, right? The stuff they were trained on. They can't just tap into live company databases or, actually do something like book a flight on your behalf.
They're stuck in their digital box.
Exactly. And the historical problem, as the sources describe it, was this fragmented mess. Every AI tool needing custom-built connectors to talk to every application. One source called it the connection explosion problem or an integration nightmare.
The N times M problem.
Right. Imagine building a unique bridge for every single AI app to connect to every single external system. Salesforce, Slack, your internal database.
It's completely unscalable, labor-intensive, brittle. Just a huge pain point for developers trying to build useful AI applications.
Which leads us, I think, to the solution presented in the sources.
Exactly. This is where the Model Context Protocol, MCP, really steps in as a potential game changer. Anthropic introduced it as an open standard back in November 2024, and its core purpose is to solve that exact problem. Connecting large language models to real-world tools and private data securely in a standardized way.
Yeah.
So they can not just analyze information, but actually act on it.
Okay, so how does it do that? You mentioned a universal adapter analogy earlier.
Yeah, think of it like USB-C for AI. You know how USB-C lets you connect your laptop or phone to all sorts of different things? Monitors, drives, power with one standard port. MCP aims to do that for AI models. It provides a standard, uniform way for an AI model to call an external function, maybe retrieve some data from a database, or use a predefined prompt or template.
So it's the universal connector.
Pretty much. It transforms the AI from this isolated text processor into something that can seamlessly integrate with, well, almost anything.
Wow.
Search engines, code interpreters, enterprise software like Salesforce or SAP, your company's internal tools.
Okay, and how does it work technically? Is it complex?
The basic architecture is actually pretty straightforward. It's a client-server model. The AI application, the host system, runs an MCP client, and the external tools or data sources run as MCP servers.
Right.
The client handles managing the interaction, figuring out which tool the AI needs, and structuring the communication securely between the AI and the tool server.
You said it standardizes things. What exactly does it standardize?
Good question. MCP focuses on standardizing 3 core concepts or primitives. First, prompts. These are like user-controlled templates or instructions that guide the AI's behavior, setting the stage, basically.
Okay.
Second, resources. This is contextual, read-only data. Think file contents, database records. It's like making a JET request in web terms, just retrieving information.
Got it. Read only.
And third, tools. These are the active parts. Model-controlled executable functions, things like writing a file, updating a database, making an API call to book that flight. This is more like a PO3 request. It actually changes something or takes an action.
Prompts, resources, tools.
Yeah.
Okay.
And this structured approach, it builds on earlier ideas like OpenAI's function calling, but MCP really aims to make these interfaces universal.
And the benefits. Less custom code, I imagine.
Definitely. Rapid tool integration is a big one. No need to write bespoke code for every connection. It also empowers more autonomous behavior because the AI has a standard way to access the tools it needs, reduces friction for developers, ensures consistency, and it supports this ongoing two-way dialogue between the AI and the tool. It's not just a one-off call. So it really helps turn that isolated AI brain into a much more versatile doer.
What really jumped out at me from the sources was how fast this is moving. It's not just a proposal on paper.
Not at all. It's gaining real traction.
Yeah, the sources show major players getting on board. OpenAI added MCP support to their Agents SDK in March 2025. Then Google, Amazon, Azure followed suit with their agent frameworks in April 2025. That's pretty rapid adoption by the big cloud provider.
It's a huge endorsement. It signals that this standard has serious momentum.
And it's not just the platform providers. Companies like Block, formerly Square, And Replit, the coding platform, they're already using MCP, connecting their AI assistants to internal tools, databases, ticketing systems, customer profiles.
Right, enabling their AI to pull live data, help teams make faster decisions, all within their secure company environment.
Microsoft's Copilot Studio 2, integrating MCP, makes it easier to hook AI agents into business tools like Dynamics 365, Office, Teams. It feels like it's becoming a foundational layer for enterprise AI.
It does. And the ecosystem of actual MCP servers is growing incredibly fast. It is really diverse. You're seeing official ones, community-driven ones,
For what kinds of tools?
all sorts. Enterprise software, definitely Salesforce, ServiceNow adapters are popping up. Desktop automation tools like controlling the file system or web browsers with Puppeteer.
Huh?
Productivity tools, Slack, Google Drive, Todoist, and even tools for developers like GitHub for code management or Grafana for monitoring. It really shows the breadth of where this can be applied.
So, boiling it down for the listener, what does this actually mean in practice? What kind of applications does this unlock?
The use cases become much more powerful and practical. Think about customer service. An AI agent using MCP could access live order history, check support tickets, understand the context.
And potentially resolve the issue directly, maybe even trigger a refund.
Exactly.
Yeah.
Faster resolution, less waiting.
Yeah.
Or content creation. An AI could draft text, then use an MCP tool to check grammar, another to push it directly into your content management system, maybe even post it to social media, streamlining the whole workflow.
Research seems like another obvious one.
For sure. Querying academic databases, pulling specific papers, or business intelligence connecting to live sales data, generating real-time analysis for quick insights without needing a data analyst to manually pull everything.
Okay, so the potential is huge, but with more power and autonomy comes, well, responsibility and risk. What do the sources say about the security implications of all this?
That's a critical aspect, and the sources definitely highlight it. As these agents become more autonomous and interconnected via MCP, security and reliability are absolutely paramount. There are several key risks. Well, one major one is called the confused deputy problem. Imagine an MCP server, maybe one for interacting with your company's HR system. It might have broad permissions itself. The risk is that it could mistakenly execute an action using its broad permissions instead of the much more limited permissions of the actual user who asked the AI to do something, potentially leading to unauthorized data access or changes.
Ah, okay, so the permissions need to be carefully managed.
Precisely. MCP does define authorization using OAuth, which is the standard way websites let you log in using, say, your Google account secure access delegation. But there are ongoing community discussions about refining that specification further for complex enterprise setups.
What about the servers themselves? They're running code, right?
Absolutely. And that brings in supply chain risks. Just like any software, you need to trust where your MCP servers are coming from. Are they from a reputable source? Are the components signed to verify their origin?
So vetting the tools.
Yes, and building them securely. Using practices like SAS static application security testing, which scans the code for flaws, and SCA, software composition analysis, which checks for vulnerabilities in the open source libraries they use. It's about finding problems before they get deployed.
Makes sense. Any other big risks?
Yeah, a couple more stand out. Unauthorized command execution, especially with MCP servers running locally on your machine. They could potentially execute any code. So things like command injection, where malicious input tricks the server into running bad commands, are possible if data isn't handled very carefully. Running these local servers in a sandbox, an isolated environment, is strongly recommended.
Right, containment.
Then there's prompt injection. This is a tricky one for LLMs generally. Maliciously crafted prompts, maybe hidden or obfuscated, could trick the AI into doing things it shouldn't, leaking private data the MCP server has access to, or taking harmful actions.
How do you defend against that?
It's tough. User confirmation before taking sensitive actions is one key mitigation. Or restricting the agent's capabilities significantly. It's an ongoing research area. And finally, there's tool injection. Imagine using a seemingly safe MCP server, but later its developer modifies the tools it offers, maybe to secretly gather confidential info, or they just use deceptive names for tools.
Icky.
Yeah, so things like pinning server versions, so you know exactly what code you're running, and getting notified if the server's code changes become really important trust mechanisms.
Okay, so there are definitely challenges, but are there clear best practices emerging for people who want to build with MCP now?
Yes, absolutely. Despite the risks, the community is figuring out how to do this well. The sources highlight several key practices. First, use structured frameworks. Things like LangChain or Pydantic can really accelerate development and provide built-in safeguards.
Don't reinvent the wheel.
Exactly. Second, design your tools very precisely. Give them clear, specific descriptions and scope. The AI needs to know exactly what a tool does, and just as importantly, what it doesn't do.
Clarity is key.
Third, limit the cognitive load on the AI. Don't overwhelm it with hundreds of tools at once. Keep the tool set under, say, 100 per interaction, exposing only what's genuinely needed for the task at hand.
Makes sense. Keep it focused.
Fourth, continuously evaluate the AI's outputs and its reasoning paths. Is it making sensible choices? Is it using the tools correctly? You need monitoring. Fifth, think modularly. Use server boundaries. Generally, one MCP server per external system makes things clearer and more flexible. Don't lump everything into one giant server.
Okay.
And finally, critically, secure those interactions. Use proper authentication, like OAuth, for the front-end MCP clients that the user interacts with. Verify who is asking the AI to do something.
That seems foundational.
It is. And we're also seeing complementary protocols pop up, like Google's A2A, agent-to-agent protocol. While MCP handles connecting agents to tools, A2A is more about how agents talk to each other, coordinate, share information. It hints at this future where you have ecosystems of specialized agents working together.
Fascinating. So MCP is the tool layer, A2A is the dialogue layer.
Kind of, yeah. It suggests a more sophisticated, layered approach is emerging.
And this isn't just for elite tech giants, right? The sources mentioned accessibility.
That's a really important point. MCP is developed as an open-source project on GitHub. Anthropic provides comprehensive documentation. There are official SDKs, software development kits in popular languages like Python, TypeScript, C#.
So developers can just grab them and start building.
Pretty much. And there are even free courses available. Hugging Face partnered with Anthropic on one designed to take someone from being a beginner to actually building their own AI apps that leverage MCP.
So the barrier to entry is deliberately being kept low.
It seems that way. They want developers to adopt it and build the ecosystem.
So wrapping this part up, what's the big picture impact of MCP enabling this world of AI doers?
I think it means AI assistants move from being these kind of isolated geniuses, good at one thing, to being well-equipped engineers or versatile assistants. They gain the ability to interface with loads of different systems, follow complex procedures, fetch data, create information, take action, all through this unified, secure standard.
That is a powerful vision, and it feels like it's happening much faster than maybe people realize.
It really does seem to be hitting an inflection point.
Okay, so today we've really dug into this evolving world of AI agents and the Model Context Protocol. We've seen how AI is shifting from just talking to actually doing, becoming these proactive agents interacting with the real world. We explored those integration headaches of the past and how MCP offers this elegant universal adapter solution. And we looked at some really concrete, real-world applications that are already taking shape.
Yeah, from customer service to coding to research.
And critically, we also touched on the security side, guarding against things like prompt injection, ensuring proper authentication. Because as these agents get more powerful and autonomous, our responsibility in deploying them safely and ethically just grows massively.
It's absolutely crucial. We need that trust layer.
So looking ahead, here's something to think about. If AI systems really are on track to reliably handle month-long projects, orchestrating complex tasks across all these different systems, thanks to things like MCP, what does that mean for how we work with AI?
What new kinds of human-AI collaboration become possible?
Exactly. How might that reshape entire industries? And what problems, maybe ones we thought were previously unsolvable, could we tackle together with these more capable AI partners?
It opens up a lot of possibilities.
It really does. It points to a future where your AI isn't just a source of information about the world, but an active participant working within it. We've sort of laid out the roadmap based on these sources. Now it's up to all of us to navigate what comes next, with both excitement and a healthy dose of caution.